Hi everyone, welcome to our channel ISM201, and we are from Bhutan CST, and we are going to solve a question regarding the Schering Bridge. So let's start our video. The question 1 says a backlight of 4.5 mm is thick is tested at a frequency of 50 Hz between the electrode 1 mm diameter. The Schering bridge employs a standard air capacitance C2 of 106 picofarad capacitance, a non-reactive output of 1000 by pi ohm in parallel with a variable capacitance C4 and a non-reactive variable resistance R3. Valence is obtained with C4 equals to 0.5 microfarad and R2 equals to 260 ohm. So we are asked to calculate the unknown capacitance, power factor, and relative factor. So this is the circuit diagram for this question. So here is the solution. So we have a balance equation: Z1 Z4 is equals to Z2 Z3. So from this, solving this balance equation, we get R1 equals to C4 divided by C2 times R3. So by putting these values in this formula, we get R1 equals to 1.23 times 10 raised to the power 6 ohm. So in order to find the value of C1, we have the formula from the balance equation that R4 divided by R3 times C2. So we have R4 equals to 1000 divided by pi ohm, then R3 is 260 ohm, and C2 is 106 picofarad. Solving this, putting this into calculator, we get C1 equals to 130 picofarad. So this is our value of capacitance. So to find the relative permittivity, so we have C1 equals to ER inode times area divided by D. So ER equals to C1 times D divided by inode times A. So we have obtained all the values. So putting this into calculator, we get relative permittivity equals to 5.9. And to find the dissipation factor, which is represented by D or tan delta, so D is equals to omega C1 times R1. So omega is equals to 2 pi f. So the frequency is given as 50, and so substituting this into this formula, we get dissipation factor equals to 0.05. So to continue with the second part of the question, so the question says the arm AB has the capacitance of C1 of 0.5 microfarad and R1. This R1 is equal to 1K. So the arm AD has the resistance R2 of 2K. Then C3, this is C3 is capacitance which is connected in the arm BC, and we have unknown resistance. This is unknown resistance and capacitance. So to find the solution, so we are going to use this circuit diagram. From this circuit diagram, we get the balance equation. So the balance equation for this circuit diagram will be Z1 Zx is equals to Z2 Z3. So from this equation, we get Rx equals to C1 divided by C3 times R2. So C1 is 0.5 times 10 raised to minus 6 divided by C3 is also equals to 0.5 times 10 raised to minus 6 times R2 is 2K. So the resistance Rx value is equals to Rx value is equals to 2K ohm. So to find the unknown capacitance, so Cx will be R1 divided by R2 times C3. So we have R1 equals to 1000 divided by R2 is equal to 2000 times C2 is 0.5 times 10 raised to minus 6. So solving this, we get the Cx value equals to 0.25 times 10 raised to minus 6 farad. So this is 0.25 microfarad. So the second part of question, so we are asked to find the dissipation factor. So dissipation factor, so which is represented by D or tan delta. So dissipation factor is given by omega times Cx times Rx. So omega we have 2 pi f. So in this question the frequency is equals to 1000 Hertz. So substituting this, we get 2 pi f times 1000 times. So from the previous part we got that Cx equals to 0.25 times 10 raised to minus 6 times Rx equals to 2000 ohm. Solving this, we get 3.14. So this is for the today's session. So if you have any doubts, you can write in the comment section below. And so last, don't forget to subscribe our channel